Hello everyone, welcome to another episode. My name is Anton Babenka. Today we have an episode about Crossplane. And I have to say that this is one of the tools which I was actually looking forward to learn about myself. Because, not because it's Kubernetes, no, not because it's in the code and then have it created. So let's see how it is gonna to work out today. So today I have Viktor Farcic, who is gonna to join me in a few minutes, and we will be talking about Crossplane, and we'll be talking about different things related to Crossplane. As I said, I want to learn myself, and I want to kind of explain to some other people how Crossplane and Terraform can live together, and whether they should live even together at all. Like when I was starting thinking about it, I was like, oh yeah, maybe Crossplane at some point will just replace Terraform completely. And then after a couple hours of reading and clicking and talking to people, I figured out that, well, no, Terraform will stay there forever. And then again, after I after I watched some talks by some other people, I realized that no, these two tools will have to coexist for quite some time because they are rather different. So let's get started. First of all, let me share my screen. I have a lot of notes and a lot of questions which I will be asking Viktor in a few minutes. So if you guys have any questions you want to ask Viktor or myself, please write it in the comments field in YouTube, and we will cover them. So, first of all, let's see. Yes, you should see website of Crossplane. So, Crossplane. Well, Crossplane, what is it? I will start by by talking about what is it from my perspective as a not experienced user in Kubernetes ecosystem. So, if I mixed some terms, that's maybe on purpose because, well, I thought about this slightly different yet. So what is Crossplane? Well, when we go to Crossplane, we can see that Crossplane open source Kubernetes add-on enable platform team to assemble infrastructure from multiple vendors. Well, when you see infrastructure from multiple vendors and you are not a foreigner to Terraform, you think that, well, this is exactly what Terraform can do as well. Yeah, exactly. So, and expose high-level self-service API for application teams to consume. So at some point, we definitely understand that, okay, we describe Terraform code, then we execute it, then we have something as Terraform output, which we can give to different teams, and they can get, let's say, a database endpoint or different users or passwords, whatever we output to them. But there is no API for Terraform as such. And self-service API is something what you can utilize different tacos like M0 or Scalar or Terraform Cloud. They all have different possibilities to interact with Terraform, so you can do something like that in Terraform. Whether you should be doing this or not, that's another question. And the last thing is without having to write any code. Well, I never believe into this without having to write any code because YAML is, well, okay, YAML is not code. I get it, yes. YAML is not code, so you will never write code. But okay, in general, it gives pretty decent kind of understanding and, quite good. Then if I look further and I try to understand, okay, what are actually different components which Crossplane is utilizing, I have to say that when I see a description like this, quite instantly the concept of Terraform modules comes to my head pretty much instantly. Because in Terraform we have Terraform modules which people can reuse to create a reproducible piece of infrastructure. That's exactly what we get used to operate. Crossplane has slightly different concepts. So one of the things which Crossplane kind of builds on top of, I mean, what you can, the bottom level of you use in Crossplane is quite obviously is Kubernetes ecosystem. Like if there is no Kubernetes ecosystem in your environment, sorry, but you cannot use it, and you cannot, well, actually utilize any of the features which we are going to talk about. So another thing which, as I mentioned earlier, the difference between Crossplane and Terraform is that Crossplane operates on the level of like control plane, where you use API, you use Kubernetes API for everything stored in terms of Crossplane. In Crossplane is stored in etcd, while Terraform is slightly different. Terraform is command line tool, and it's unlikely that it will be changing this direction in the foreseen future. At least that's what I can see. So Terraform is executed from command line, while Crossplane is control plane. And well, that's pretty much it. So on this note, I think it's enough to go to Crossplane documentation, because, well, that's how it is. Let me bring our famous guest, Viktor Farcic. I don't think you need to have an introduction. I mean, but let me see, you are muted. Well, where to click? Let's click here. Yeah, fantastic. Great. So
there I am.
Yeah, that's really good to see you. And then let me make you a little bit bigger, because you normally occupy half of the screen. So at least in most of your talks, you divide screen on like 3-4 parts, and then you say like, oh, this is for Terraform, this is for Pulumi, and this is for Crossplane, and this is for my beautiful face. Well, now we have two beautiful faces. So, so that's how it is. Yeah, maybe there are people who don't know what you are doing, and can you introduce yourself and explain like how do you end up going from Jenkins to talk about Crossplane?
Yeah, so Jenkins, that was a while ago. Yeah, so I did everything, kind of developer, ops person, team lead, manager, stuff like that, right? For quite some time, I work as developer advocate. I've been changing companies. One of them was CloudBees, that was Jenkins focused something. Couple of companies in between, and now I'm in Upbound. So I'm very biased today, right? Now, TLDR, I kind of, if you watch the dates and stuff like that, I started using Crossplane a while ago, long before I joined Upbound, and then kind of I liked the project, and I chose to work on it actively. Or if you want it put the other way, I chose them to start giving me a salary for doing that. Yeah, now I'm a developer advocate at Upbound. So
yeah,
that might be important. I'm biased, or not, depending on how you look at it.
Well, I think that's really good that you are biased and you can talk about Crossplane in rather precise way. While I cannot talk about Crossplane so much, I can probably talk about Terraform while I'm not employed or I have no affiliation with HashiCorp. I just know this tool fairly well. So on this note, I think it's quite interesting to hear your your high-level opinion on two of this tool. Can you maybe talk about just like a short pitch why these two tools are different, or like top two items where they're different?
So I think that the major difference is, basically you said it already, the major difference is that Terraform, just like basically any other infrastructure as code tool, is based on CLIs. You define something in whichever format you define that something, you have CLI that transforms that something into API calls directly to a vendor, API calls directly to AWS or Azure or whatever you're using, right? And that's in a way, and I'm simplifying now, and I might be wrong and you correct me, that's in a way similar to if we would be working with applications, we would SSH into a server and do something, right? Now, Crossplane is Kubernetes-based solution, right? And that means that we get standard API, which is Kube API, extended, right, to manage things outside Kubernetes clusters, actually inside as well, but that would be a separate subject. I think that we are sticking with infrastructure, or
Yeah.
we can go into applications as well. And we have control plane that is Kubernetes control plane, again, extended, that is managing, orchestrating everything happening, right? And Crossplane is constantly monitoring the real resources and comparing them with the desired state, what you define in YAML in this case, and making sure that those two are always in sync. So basically, drift detection and reconciliation could be one of the differences. Now, I know that you can do that in Terraform, so it's hard to say whether that's a real difference or no real difference, right? So API control plane, and another one is compositions, which, as you mentioned before, are conceptually, from some point of view, maybe similar to modules, but yet somehow different. But in any case, point of compositions is to be able to create your internal platforms, internal services, right? So basically, ops people can create services for the rest of the company to consume in a way.
Yeah, this is definitely what we will be talking in a bit later phase, because this is a little bit more advanced for myself to even understand what exactly is a use case. So I spent probably a couple hours watching Kelsey Hightower talks on these subjects and try to understand, okay, that's what you are thinking. So there is also a question in the chat, so I will put them maybe a little bit later, because I feel we have a little bit other topics to cover before they're relevant. So, but I see these questions, so don't worry, guys. So when we're talking about reconciliation loops, and you say that in Terraform you can achieve similar stuff, I think this is quite important to understand. Everything is possible. You can write bash shell script if you want, right? I mean, I don't want to share the link of Kubernetes written in shell, but there is such product. There is a project on GitHub with many stars. I think it was created by a guy who said, like, why do we need all of this Kubernetes ecosystem if you can do this in shell? And there are thousands of lines in shell. It's quite hilarious to see.
Now you messed up with my brain. Everything I'm trying to think about is to remember the name. What is the name? I know the project. I used it even, and now I forgot the name.
I don't remember, but hopefully none of our watchers or listeners will be using this. But we can definitely do a lot of things in, as I said, in Terraform. There are different utilities. For example, driftctl was created with an idea that, hey, we will help you with drift detection because Terraform natively cannot help it. While in Kubernetes, there is the core principle of reconciliation loop. And where we can look into different, or not differences, but if we look into different projects or different options, how Crossplane can be integrated. I think it's quite important to bring this question. Can you see the question? No, I should put it somewhere. I should put it maybe, well, I'm too big for this screen.
You need to put the question in front of you, not behind.
Well, but it's too hard. Let's put it somewhere here. Okay, like this. Can you read it?
Yes, at least I can read it. Shall I answer?
Yeah.
Yes. So there is a project called TerraJet ongoing right now, which I think that Anton will bring up at one moment. And the goal of the project is to increase the provider coverage of Crossplane by using code generation from Terraform. So basically, it's not really bringing incorporating Terraform into Crossplane, but rather using Terraform providers. Is it called providers or modules?
Yeah.
Anyways, use Terraform modules to generate code that becomes Crossplane providers.
Yeah,
That one, exactly. Because really, what makes Terraform absolutely amazing, I mean, there are many things that makes Terraform amazing, but Terraform likely today has the biggest coverage, provider coverage in the world, right? And
yeah, and
we are using that.
this is exactly the goal of this TerraJet project, is that instead of building your own solution and try to understand how to mimic Terraform, you can just utilize Terraform providers as much as possible and hands off all of the generation to that. So then I think it's quite important to understand and to discuss what are actually the points in doing this. I mean, okay, Crossplane is taking care of making sure, like, simple language, like Crossplane can be used to make sure that resources stay in the configuration as they were described initially. And it will perform certain operations, and it will do certain things. Well, that's why, that's the whole idea, which is inside of so-called reconciliation loop. If we are utilizing these Terraform providers, what is actually the thing which we, let's say, cannot be doing using just Terraform providers in this sense?
So to begin with, this might be misleading a bit. So this will not allow you to run Terraform HCL in Crossplane. This generates Crossplane definitions that you would use, have to write from scratch to use, right? This is more about increasing Crossplane coverage than bringing Terraform in, right? Bringing Terraform in would be the other provider, the provider Terraform or something like that, right?
Yeah.
Exactly, that one. So
Yeah.
the first one is internal thing. It's a way how we want to very quickly get huge coverage. And
Right.
that TerraJet is kind of temporary thing. And when I say temporary, I'm talking temporary as in years to come, temporary, but not infinity. Because in parallel with TerraJet, there are Crossplane native providers, which are kind of more powerful, do better job from Crossplane perspective, not Terraform. But it takes time. I mean, you've been probably in Terraform for a long time. It took a lot of time for Hashi to get to the level of providers it is, and same thing for us.
Well, it's actually quite interesting when you say that native cross-plane providers. This reminds me Pulumi, where Pulumi started with using Terraform providers completely, and then they start to implement their own specifics and making more like native Pulumi providers for some things. So it's similar path.
Because the way how, like you mentioned, among other things, reconciliation loop, right? Native providers in Crossplane do a better job of doing that. They're doing faster, more less performance issues and stuff like that, simply because they're designed to go directly to Kubernetes API, communicate between Kubernetes API, provider API, and do that more efficiently, and so on and so forth, right?
Yeah.
So that's why they're better. It's what you said before, right? Which I could kind of what you said before is that my interpretation of your words is, hey, there is a difference between this can be done and this is designed to do this specific thing, right?
Yeah, exactly. Yeah, but I think that it's really beneficial to stay on top of existing Terraform providers and utilize. Now there is a Terraform provider SDK, I think version 5, which means that people were improving it and constantly thinking about different use cases, and it's being developed very, very thoughtfully. So I think it's really a good starting point for many of projects. But let's switch gears a little bit to talk about this project. I really like the word experimental here because when I when I look into this one and I see YAML code combined with HCL code, and my favorite Terraform workspace being used here is like
Yeah, yeah.
can you explain like two things, probably worth explanation is crossplane composite resources. What is it? And second is how this thing's supposed to be working. If you can explain what's
Yeah.
the point of this.
So the first half of that definition, the things that are, until you get to the module part, that's in a way, give or take, unavoidable Kubernetes type of definition, right? So
Yeah.
you have to have that no matter what you do. Doesn't matter whether we're talking about Terraform or we talk about something else. This, at least until spec, you need to define it in Kubernetes no matter what, right? That's
Yeah.
a standard thing. And basically, what I cannot even imagine a different way to incorporate anything in Kubernetes that is not Kubernetes native in a way or designed for Kubernetes, right? So yes, this is double the size of a number of lines that you would normally have to do for Terraform, but it's in a way unavoidable. Nothing to do with Crossplane, I believe.
Yeah.
And this basically allows you to run Terraform inside Crossplane. It's kind of for people who. So normally, it's quite okay, at least from my perspective, for the 2 tools or 3 tools or 4 tools to coexist. I know people who use Ansible and Terraform together today, right? And same thing can be for Terraform Crossplane. Now, and if they coexist, that's quite okay. But then there are some situations in which you want to that relation to be a bit tighter. Because let me just see the example, right? Now, if you look at the last line there in the first example, right, connection secret to ref, right? So if you use some other Terraform, if you define some other stuff in Crossplane, they're likely going to use Kubernetes secrets with information stored from some other resources to do something else. Like, let's say that this creates a Kubernetes cluster and you want to use something else to connect to that cluster and do whatever, right? This would allow you to do part of the work that Crossplane would natively do. Like, hey, I want to run this Terraform stuff, and I want to write it to the secret, some output, so that some other Crossplane resource can benefit from it. So it's maybe best for those use cases where people want to start using Crossplane, but want to reuse some parts of the code, not necessarily to move the whole Terraform code base into this. Kind of that would not be I wouldn't do that, to be honest. Thousands and thousands of Crossplane HCR files moving into this would not be the solution.
Yeah, I absolutely agree that it's probably a good example to have it when you have like one resource, 2 resources, 5 resources, fine, but absolutely not everything. And then there is a similar approach, which is like, hey, this module is hosted somewhere here, and then just pass these vars and var files to this module. So this is similar. I mean, in many situations, that's how we encourage people to use Terraform. Is that they should write modules and then reuse these modules and focus on what kind of inputs they specify there. So this is a quite nice way. But again, this approach is pretty good as long as you don't see this stuff which is hosted somewhere here.
Yeah, if I would be doing this, I would go with the second example.
Yeah.
Right. Much better. At least you don't do copy and paste.
Yeah, and as you mentioned that this is a typical Kubernetes manifest format. So this is how it looks like. And if we look into HashiCorp Kubernetes provider, well, there is somewhere, here is it, Kubernetes provider or Kubernetes Alpha provider, it already has a lot of different resources here. So let's maybe, well, let me see. Well, we can talk about some things related to this, like integration between Kubernetes provider and Crossplane, or I think it's better to actually see your demo. Let's see your demo. I'm sure that you have the demo. Let me put it somewhere here. Let's see, this is your screen.
Okay.
And we have just disappeared. Let me add you. No, this is bad. I'm clicking everywhere. It's typical. Okay, now we can see you. Good. So let's see you. Yeah.
Let me show you a couple of things. So take a look at this YAML. Now, I will try to go fast so that we have as much time for questions or discussion. So, but if you want any details, let me know. So, in most of the cases, we do not use Crossplane directly. We create compositions which is similar, not similar, but conceptually in a similar direction like modules in Terraform. And in this case, I'm creating an open API schema that says essentially, hey, this new interface, new composition will have some parameters, and these parameters will be version, size of the nodes, minimum number of nodes, right? It can be anything. This is just an example, right? And then I have, where is it? I think that you're not sure. Config composition EKS, implementation of that in EKS, right? So that schema can have 1 or 1,000 different implementations, exactly the same schema, which is maybe one of the differences. And here I'm specifying what you need to create a cluster in EKS. Now this is EKS, sorry, this is AWS, so this is huge. AWS is always big. Where is it? Here. I'm creating, where is it? EKS cluster here, using stuff from some parameters, and I'm creating a node group using other set of parameters. This is Crossplane / Kubernetes way to patch things like, hey, if somebody specifies a node size to be small, then convert this to T3 small and things like that. And I have other resources. A lot of stuff, because a lot of stuff is required to run, let's say, a cluster in AWS. And this is kind of, and when I say a lot of stuff, it doesn't really matter which tool you use. You need to define a lot of things. And then I'm defining, what is it here? I want that cluster to have Prometheus running inside. Okay, so that would be from the operational perspective, right? It's SRE, DevOps, whatever we call each other these days. And then I can say something like, hey, implementation of this or that interface, this is what users would be seeing. They would be using a new resource type in Kubernetes called composite cluster. This does not exist. This was not created out of the box by Crossplane. This is basically what that API schema, Crossplane converts that API schema I showed before and creates a completely new Kubernetes resource that is called whatever you want it to be called. And then I say, hey, this is the implementation I want to reference. Those are the parameters that I commented before. And that's about it. And now I could do two things. I could do kubectl apply. File name would be whatever this file name, right? And then my Kubernetes, this would be sent to Kubernetes API. Crossplane would pick that up because from this moment on, Crossplane is monitoring all the events related to this this definition and this resource type. And if I do that, I would have my Crossplane will start managing all those AWS resources. But I will not do that because instead I will, and this is kind of the important thing that helps Crossplane a lot. Since it is Kubernetes native, that means that you can combine. That means that Crossplane does not necessarily need to implement everything. you can combine it with other projects in the ecosystem. And in this case, I already have in this cluster, in the management cluster, Argo CD running. So instead of me directly communicating with Kubernetes cluster, I will do this. I will move that file that I showed you to a directory. I will add those files, push them to the Git repo, and then I will start watching what is happening in my cluster. kubectl get managed. Get managed is a shortcut in Crossplane to show you all the Crossplane resources. This can take a few seconds until it's executed, and while that is happening, let me switch to this.
Sorry, there is a question already by Enrique. So he's asking, so is it like reusable YAML code? What you showed, composition.
Yes, Enrique, I guess you're talking about, where is it? This one.
Yeah.
Yes. This is basically a way for operations to create a new resource, a new type of Kubernetes resource that everybody can use, right? So you're creating completely new entity in Kubernetes.
Right. So if we are talking, just to put it in perspective of Terraform, it's like Terraform modules on steroids.
Exactly.
Where
exactly.
you have some code which you want to kind of be executed, but you usually don't have enough specifications like how to call it, what exactly to pass. So people will have to guess what kind of API is actually there, so they can get it from somewhere.
Yeah, you're kind of like enabling, exposing certain things that matter to everybody, and then hiding the rest of the complexity required to do something, right? The major difference, I think, and correct me if I'm wrong, Anton, because I'm not that proficient in Terraform. When you do modules, you cannot do something like this, composition reference, this one. You cannot reference which of the X implementations of that module you want to use. Or maybe I'm wrong.
Well,
you could do some if-else statement, right?
Well, not so much. I mean, yes, you can reference to something, but you have to be more precisely, like not just the whole cluster. You probably need to specify which properties of this cluster AWS you are actually interested in. It's not one big thing. It has to be much more precise. It sometimes can be like this, but it's not so common, I would say. You have to implement differences yourself very much. Like what is AWS specific, what is Google specific, Azure specifics. So there is no way to write some generic code like this. So Terraform is not helping with it.
Let me go back to my screen. Oh, if there are more questions, please do. I prefer answering questions than...
So the question is, I wanted to see there is a parallelism with Terraform modules. Not sure I understand it.
I mean, parallelism as in similarities, there are some similarities. I mean, on a very high level, both this and modules allow you to create new definitions of something, right?
Yeah. Well, but parallelism here, I guess we are kind of offloading these things to Kube API, and we let Kubernetes to figure out how to achieve this, in which sequence, how parallel it can be, and so on.
Parallel execution. Yeah. That's also kind of that's one of the differences, I think, and this is very much Kubernetes related, is that outside Kubernetes, you can do things in parallel, but then you need to wait until some things happen until you can do some other things, that depend on parent-child relation type of.
Yeah.
In Kubernetes, you usually do not wait you do not wait for dependencies. You're kind of like more like trying to do things and then failing and then
Yeah.
trying again in a way.
Yeah.
So if I show you the resources, and I will do that when now, you will see that some of them are just kind of like trying because cluster is still not available.
There is a just follow-up question by George. Is there a plan to use some conditional logic within compositions?
Okay, that's excellent question. Anton, can you remind me of this question like in 5 minutes? Let me just show this quickly, this demo, and I'll answer the question because it's really cool.
Yeah.
So very quickly, here is Argo CD, right? And I want to show you that you can actually combine, mix and match almost anything from CNCF because they're all kube native. And you can see that, so I did not really execute any CLI command, create this. I did not communicate with Kubernetes. I let Argo CD synchronize what is in my Git repository with my cluster. And you can see that I got this composite cluster over here. And those are, and these are all the AWS resources that were created out of that, right? And my cluster, and I can get you the same example here. If I go to my terminal, you will see in maybe 5 seconds that it is working on creating all those things. It's all happening in parallel, except that some of things are failing because some others are not there yet, which is a normal behavior in Kubernetes. Now, there we go. And you can see here that it created a security group, route table, subnets, VPC, internet gateway cluster, node group, and a few other things that are below that you don't see because my resolution is a bit low. So that's that. Now let me go back to the question, if that's okay, from before. What was the question? Something about conditionals, right?
Is there a plan to use some conditional logic within compositions?
Yeah, the plan is no, at least not right now. And the reason, one of the reasons, and that's I would say benefit of being being Kubernetes native, is that instead of us planning to do something like that, we can just leverage any of the tools that already do that in the ecosystem. So let's take a look. Take a look at my screen. I will show you. Let me find an example. So I'm bringing it a bit right now. Let's say that you like within Kubernetes to use Helm to do those things. And then you could do something like, if I ever find cut charts, let's say AWS, and let's say that you want to use some, what did you say, conditional logic. You could do something like this, cluster, and let me find an example. So for example, here, I'm looping through all the zones specified in the values file and creating subnets. So instead of having a subnet defined 3 times, I can define it once and then loop through values. This is not Crossplane doing. This is now Helm doing those things. And I'm pretty sure that somewhere here in this example, I have conditional logics like if-and statements and what's or not.
Yeah.
So short answer, Crossplane doesn't do that. The longer answer is that any of the tools that you would be using to do that within Kubernetes, you can apply them to Crossplane.
Right. Great. I think quite interesting continuation of this one is that you showed the way how you created a bunch of AWS resources, and I'm not sure what exactly you used for that one. I mean, whether you use provider Terraform or provider AWS Crossplane.
Provider AWS Crossplane.
Right.
In this case.
Provider Terraform has a quite interesting concept in this regards as well. Right, so provider Terraform is just calling Terraform like internally, and that's pretty much it. That's all what it does, right? So provider Terraform has possibility to run Terraform CLI internally and it can execute any Terraform code you give to it. But I'm not quite sure what is the way to integrate these two tools. I mean, I understand that it's executing Terraform like internally, but can I somehow see Terraform plan if I'm using provider Terraform? Because seeing what's gonna to be applied is really useful, at least for people using Terraform nowadays. Is there any way for me to kind of predict what's gonna to happen?
Predict what? So it is possible, which is a very bad substitution, to see the difference between on a manifest level, but not on a level of real resources. So there is no equivalent of real Terraform plan, and I think that's kind of again a bit outside of the scope of Crossplane, because in general in Kubernetes you do not know in advance what will happen, what will Kubernetes do, and that's I wouldn't say a problem, but that's something that, as far as I know, nobody really solved, and I'm not sure whether anybody is working on solving it, mostly because it is not that predictable and imperative what will happen, simply because you are not in full control anymore when using control planes. And this is not really necessarily directly Crossplane answer, but Kubernetes in general, because you're letting the control plane do the work and make decisions for you.
Yeah,
and
exactly.
Then you do not know what decisions will be in advance.
Exactly, but that's pretty much the biggest sales pitch which we used to have in Terraform since early versions, is that, hey, you can see what's going to happen. And now we have to say to people, oh yeah, but thank you for your Terraform configurations. We will do our best to apply it. Maybe we will succeed, maybe not, but you will not see any errors. Right? You will see errors, but only later.
Think of it this way. Let's say that we switch conversation from infrastructure to applications, right? Could you, even Terraform, if you would use Terraform to deploy applications to Kubernetes, would not be able to give you the plan. I mean, the output of Terraform plan, yes. But information, like where is that application going to run, you would not be able, nobody, including Terraform, would not be able to predict that.
Yeah.
Simply because only after it gets to Kubernetes API says, okay, maybe I should run a container of this application here, and maybe I should run it here. And 5 minutes later, even if you get the plan, there is nothing telling you that it will, 5 minutes later, it will not make a decision, hey, I should shut down this thing and move it there, right? Because you're giving away control. Now, whether that's for good or bad, for good or bad, but that's simply how Kubernetes in general works.
Yeah, exactly. This is because with Terraform it's easier to have drift. It's quite interesting. I don't think I have heard word drift during the first couple years of using Terraform. We were so happy to just apply something, and then we just rerun Terraform, apply again, and then again, and nobody were thinking like, oh yeah, now I have this bunch of things which is not in sync with something. I know that this is like flash from the past, but still, drift is not something what many companies and many environments are even aware of. So me cannot, well, this is because with Terraform it's easier to have drift, and but with Crossplanes is not easier.
With Crossplane you will have drifts, even more drifts.
Because
the major difference is that Crossplane, control plane will try to resolve those drifts. So nothing is really preventing you from having drifts.
Exactly.
The real question is who is resolving them.
Exactly. And in many situations, I have to say that when working with Terraform or TerraGrant, or if you have a lot of different Terraform configurations laying around without automation or without pretty much automated GitOps approach, there will be drift all the time. Like I just cannot imagine how would you prevent this from happening if you use Terraform. So yeah, Crossplane definitely has some solutions for that, and that's why people are using it, and that's one of the benefit of using it. Well, I have another question related to CRDs. So CRD, custom resource definitions, the way how they are created or how they are not managed, but how Upbound team is writing or is creating CRDs. I mean, you guys are generating providers, you write a lot of like low-level code. You do similar work, I mean, as we discussed earlier, what is happening in Terraform world as well as in Pulumi world. So you're doing these low-level things. One interesting thing which is happening or which can happen anytime, I mean, it's already happening, but it's not very well known yet, is that Terraform actually has possibility to export all of this information, which is 90% sufficient to create CRDs already. The command name is Terraform provider schema-json. It will output something like 4 megabyte JSON file, which contains everything what you need to know about resource, arguments, attributes, sometimes different validation, sometimes descriptions. Like, it's pretty good for CRDs. It does not contain everything, but it's very good starting point from what I understand. So I was wondering if you have some insight about how provider Terraform is being developed now. I'm wondering if you guys are looking into utilizing these JSON schemas from providers itself, or you are doing it very low level.
To be honest, I haven't had time. This is something very new. I think it started like a month or two ago, and I still haven't went through the code that actually behind TerraJet. So I think that you're talking about TerraJet, not Terraform provider. I'm guessing.
Yeah, right.
Yeah, I still haven't seen the details, to be honest, so I cannot answer that question.
Okay.
I can get back to you.
Well, the thing about Terraform provider schema is that this is strictly speaking, this is the only API which Terraforms expose. Not API, sorry, schema. Schema which Terraform will be able to expose to anyone. And
I don't think. I think it's going directly to the Go modules behind it, behind the Terraform providers. I think, but I'm not really sure. So
yeah,
don't have a good answer. What I do know is that right now within the community, there are conversations going whether actually to do that in the first place. I mean, we will do that 100% sure. But what is happening also is that since we are creating Kubernetes resources, and in parallel with those efforts, AWS, Azure, Google, they're all working also on exposing their APIs as Kubernetes native resources themselves. So there is some kind of parallel efforts going on, and kind of like now discussions. Hey, should we really use Terraform, or should we go directly to the in AWS it would be ACK and then control something in Google and so on and so forth.
Yeah, right.
So kind of everybody's going in a similar direction in a way.
Well, a few years ago, people were talking about, hey, let's do API, and what kind of API? And then kubeAPI said like, oh, this is an API. And now everyone is saying, okay, we are moving to this API direction. Okay, good. Well, there is a question by George. I think it is related to the state, which, statement, which I have heard from many people is that, hey, Terraform scale has some limitations. So it's hard to use Terraform when a lot of people or a lot of environments or a lot of modules or a lot of something is being used. I completely agree when people say that it is hard to use Terraform on a bigger scale unless they split their stuff. I mean, you have to split your stuff to many, many different things. And I guess this is a question which George is asking here. Should you start big on a composition or small in nested primitive resources? It might sound better to go small and have more compositions, which can be in later step being part of nesting in another composition. What is your suggestion on it?
Oh, I hate when people give me the answer I'm going to give you, and the answer is it depends. Compositions are a way, I mean, there are many usages for composition, but the one I like the most is enabling others to manage something, right? So you're a big expert in AWS. You want to enable, let's say, developers and everybody else to use resources, and you want to simplify it in some form of by composing things into a new resource definition. Now, whether that should be a big one that contains a cluster and a database and this and that, or it should be smaller ones, really depends on what the needs are of those people, right? I would say that you should go bigger towards bigger compositions, as long as that is not preventing people from doing stuff, right? Because, hey, if everybody needs a cluster and a database, then why not create a composition with both? Now, as long as that is not influencing your flexibility. And I'm realizing that I'm not giving you a straight answer, but I cannot. It really depends.
Well, yeah, I honestly don't like when people say it depends. I mean, it's quite easy to say, oh, it depends, and then go and figure out yourself. But if we look into this, like how we used to do things before, I mean, what we used to do, we used to make something small, and then when we understand that, oh, now I'm also using these, let's say, two resources together, then we make some sort of abstraction on top of it. We call it modules or whatever else. And then we group these modules together and we say, okay, this is how we define our bigger things like environment, for example. So this is probably similar what we can do here as well. But I'm not expert in Crossplane, so I would agree it depends.
We would need to start defining what is small and what is big first.
Yeah.
For some people, kind of like 50 resources grouped together is small. For others, that's whole system, right?
Yeah, so George says that that's why I made this one from your so far experience. Well, I think you have experience with, or at least you saw how people were struggling with one of these approaches.
I personally prefer making compositions contain the things, resources, which can be 1 or 20, that make a logical entity. So, for example, from a user perspective, from a developer perspective, a logical entity is an EKS cluster, right? That's a logical something I want. And that should be one composition, right? Now, inside of that composition, what do you need? Whether you need 10 or 20 resources to create EKS cluster, that's up to you, right? And that's why I'm saying it depends. Sometimes EKS cluster can be 50 different resources in AWS. And if you can go also minimalistic and say it has only 5, the absolute bare minimum, right?
Yeah.
But from user perspective, it is a logical entity. I would not give users, hey, this is a single composition to create a cluster and a database and this and that. That would be too big for me.
Yeah. Well, this I can rephrase this in Terraform world. There is terraformbestpractices.com where I have described exactly this approach of grouping resources to what kind of Terraform modules does it make sense to have. As Viktor says, there is no point to give 25 resources if you need to call them all at once always. For example, if you create EKS cluster, believe me, you don't want to know about 25 different resources which have been interconnected somehow. While in Terraform, it's kind of more complicated. In Terraform, we have Terraform state, which is not the easiest thing to work with. Especially once you create something, it's rather hard for us to change it. I mean, there are no automatic way to do this. There is no way to describe migration as code on a bigger scale. So you will have to do some semi-automated steps, thinking about, okay, from now on, I want to group some of my resources together. So I need to combine these Terraform states somehow. It is rather cumbersome, I would say, to do in Terraform. I think there was a question before about state. Well, what was it? Yeah, I don't see this question anymore, but there was a question about state. So the state of infrastructure in Crossplane is stored in etcd, right?
Correct.
And is there any annotation or any reference from which Kubernetes manifest it was created? Or can I refactor my Kubernetes manifest in a way that it will be seen as no changes? So from Terraform point of view, this is a really important question to get answered as early as possible. So you cannot move resource from module into another module so easily.
Sorry, I'm not. I got lost there for a second.
So in etcd, where state is stored, is there is a unique identifier for the resource, which may prevent me from moving resource between different manifests or not?
Yes, so internally Kubernetes stores, as I said, in etcd its resources, and they're uniquely identified by the API of the resource itself, the kind of the resource, the name of the resource, and the namespace.
I see.
So those four are forming the unique identifier internally, right? So exactly the same API, exactly the same kind, exactly the same name in a different namespace are a different object.
I see. Yeah, so it means that, like speaking in Terraform world, this problem does not exist in Crossplane. So you can simply move resource as long as it's the same, I mean, 4 parameters as you mentioned, then it will have the same ID, and that's good. Okay, cool. Yeah, I think that I got.
One of the advantages, I said, which is not thanks to Crossplane, is simply that Crossplane is leveraging a lot of work done by others, meaning in Kubernetes, right? etcd, we did not write etcd. It did not happen. It's just that it happens to be a very good distributed key value storage.
Yeah, exactly. And that's good that you guys didn't write etcd. Because
it would be good if it did, but I cannot take that credit.
Yeah, exactly. Well, there are a lot of other things which you wrote. So let me ask a few questions related to... If anyone have any questions, please leave comments and I will read them. I want to ask a little bit about, or maybe not ask, but more hypothetical approach. So imagine that we have Kubernetes cluster, we install Crossplane then, and then someone attended our live stream, figure out that, oh my god, I need to drop all of my Terraform code, and from now on I will be writing everything in Crossplane. And what are the steps for them to do this? I know this is very hypothetical, that's the way I like to ask it. So we have Crossplane already kind of available. we have created a lot of Terraform resources in the past. We covered Terraform, provider Terraform, which is kind of experimental, and we can look into this way to do certain things. But what else, or what are the ways for people to kind of migrate to, let's say, we have a bunch of production load already, and we want to go to Kubernetes. I mean, not necessarily a Crossplane, but to Kubernetes. So one product or one tool which existed is that if you guys have already a lot of YAML files where you describe your manifest, you can convert them into HCL files, quite straightforward, and have it there. But what if we want to do this? Let's say the main benefit, which I'd like to focus, is reconciliation benefit of the whole Kube platform. What are the ways, or what are the steps for people to migrate, let's say, existing infrastructure which they have created into Crossplane? Like, I know that the question is pretty fucked up, but
yeah, there is no. It depends really how far you want to go. You mentioned the experimental one. That's kind of like, hey, I can do it in a day. But ultimately, if you're migrating, at one moment, the things you want to migrate, and I'm not saying everything, at one moment you need to rewrite into YAML. I mean, or unless you use the Kubernetes provider, but then I'm not sure whether that would give you such drastic benefits, right? It would be similar to kind of like a question migrating from Ansible to Terraform. I'm sure that there are tools to kind of like make it somehow seem that you migrated, but ultimately, one moment you will have to write HCL.